Hello everyone, welcome back to my YouTube channel. Today we are going to study standard 10 science chapter number 4. It's carbon and its compounds. This chapter is very important for a board exam and also for understanding organic chemistry basics. By the end of this video, you will clarify understand why carbon is so special, different types of carbon compounds, hydrocarbons, functional groups, ethanol, ethanoic acids, soaps and detergents, etc. So let's begin. Occurrence of carbon is found in atmosphere inside the earth's crust and in all living organism. Carbon is present in a fuel like wood, coal, charcoal, coke, petroleum, natural gas, biogas, mars gas, etc. Carbon is present in compounds like carbonates, hydrogen carbonates, etc. Carbon is found in a free state as a diamond or a graphite or a fullerenes, etc. Carbon is a non-metal element found in a group of 14 of the periodic table. Although carbon is present in a small amount in a nature, it forms millions of compounds. For example, carbon example of carbon in daily life, it's like a food, clothes, medicines, fuels, plastics. This is why carbon chemistry is called organic chemistry, because it is so special for in this carbon bonding in a carbon covalent bond. Okay, first of all, it's also atomic number carbon is 6, it electronic arrangement is 2 and 4. It has a 4 valence electron. It can attain stability by a gain 4 electrons, losing 4 electrons, or a sharing 4 electrons with other atoms. It does not gain 4 electrons because it is difficult for the 6 proton to hold 10 electrons. It does not lose 4 electrons because it needs a large amount of energy to lose the 4 electrons. So, it share 4 electrons with other atoms to attain stability, resulting in the formation of covalent bonds. Since carbon atom needs a 4 electron to attain stability, its valency is 4 and it is tetravalent. Carbon has a 4 valence electron, so forms a 4 covalent bond. Because of this, carbon can bond with hydrogen, oxygen, nitrogen, halogen, etc. This leads to a huge variety of compounds. Covalent bond is chemical bond formed by sharing of electrons between the atoms. The sharing of one pair of electrons result in the formation of single covalent bond. Sharing of two pairs of electron result in the formation of double covalent bond, and sharing of three pair of electrons result in the formation of triple covalent bond. For example, formation of single covalent bond in hydrogen molecule, it's H2. The atomic number of hydrogen is 1. Its electronic arrangement is 1. It has 1 valence electron. It needs 1 electron more to attain stability. So, two hydrogen atoms share one pair of electron, resulting in the formation of a single covalent bond in a hydrogen molecule. You can see here this is H2. And more of the example of formation of double bond covalent bond oxygen molecule, it's O2. Carbon forms covalent bond by sharing electron, for example methane, ethane, and covalent compounds generally have a low melting point or a poor electrical conductivity also. The atomic number of oxygen is 8, its electronic configuration is 2 and 6. It has 6 valence electron. It needs 2 electron more to attain stability. So, two oxygen atoms share two pairs of electrons, resulting in the formation of double covalent bond in oxygen molecule is O2. You can see in this figure out formation of triple bond here with example of N2 nitrogen molecule. The atomic number of nitrogen is 7. Its electronic configuration is 2 5. It has 5 valence electron. It needs 3 electron more to attain stability. So, two nitrogen atoms share 3 pairs of electrons, resulting in the formation of triple covalent bond in nitrogen molecule is N2. You can see here this all our example is hydrogen atoms combine and give a hydrogen molecule, and then a fluorine atoms to combine and fluorine molecule become a fluorine molecule here, two oxygen and one carbon. So it's carbon dioxide molecule, four fluorine and one carbon. So it become a molecule of carbon tetrafluoride. You can see here, this is very important for you. Electron dot structures. Here we example use a methane molecule CH4. You can see this electron dot structure, and also ethane molecule C2H6 also. This is a very important for your exam. Please remind this, explain in your class. Formation of very large number of carbon compounds for just for a compounds of which it's a catenation. Carbon forms a very large number of compounds. The number of carbon compounds is more than 3 millions. It is more than the number of compounds formed by all other elements. This is because of catenation. First is carbon atom can form a bonds with other carbon atom to form a long chains, branch chains, and the close rings. This property is called the catenations. Second is, since the valency of carbon is 4, it can form bonds with other carbon atoms or with the atom of other elements like a hydrogen, oxygen, nitrogen, and halogen, etc. You can see here the long chain, branch chain, and close ring also. Hydrocarbons, saturated and unsaturated hydrocarbon. Hydrocarbons are compound made of only carbon and hydrogen. They are mainly divided into saturated hydrocarbons and unsaturated hydrocarbons. Saturated means it's alkyne, and unsaturated means alkene and alkynes. You can see here saturated hydrocarbons. This hydrocarbons are compound contain only single covalent bond between the carbon atoms. Alkane have a all single covalent bond between the carbon atoms and their names end with ANE. This is methane. Meth means one carbon. Eth means two carbon. You can see here. And then what is unsaturated hydrocarbon? Alkenes contain at least one double bond, or alkynes contains at least one triple bond. For example, ethene C2H4. They are carbons having a double bond or a triple bond covalent bond between two carbon atoms. This is alkene or alkynes. Alkenes have a double bond covalent between the two carbon atoms and their names with ene. Ethene. Eth means two carbon and prop means three carbon. You can remember this all the script, okay? This is all of your revision in this short video. Alkynes means have a triple covalent bond between two carbon atoms and their names and with a YEN. Eth means two carbon and the prefix you can use is eth and the suffix is YNE, ethine, C2H2. Then you can use these three carbon atom prefix is prop and then suffix is yne. This called is propine C3H4. And then next we can go of isomerism. Okay, first of all, we can see a carbon compound having the same molecular formula but different structural formula are called the isomers. This property is called isomerism. For example, butane C4H10 has two isomers. They are normal butane and also isobutane we call also. Okay, this all example you can see here. This is pentene C5H12 has three isomers. They are normal pentane, isopentane or neopentane. All three structure you can remain and please observe carefully. Next is functional groups. First of all we discuss halogen series. uh, homologous series is a group of organic compound with the same functional group or a general formula or similar chemical properties. Difference between successive members you can use it here is CH2 group also. Okay, this also called functional group. Next, an atom or a group of atoms which decide the properties of the three carbons compound is called a functional group. A functional group is an atom or group of atoms that determines the chemical properties of a compound. Here is alcohol, that is OH, aldehyde, this is CHO group, ketone, it's CO, carboxylic acid, it C double bond, C double OH, and then halides also chlorine, bromine, etc. Names with A and E. That's chloromethane, bromoethane. Alcohol names all. That's CH3OH, it's methanol, ethanol. Aldehydes calls al, methanol, ethanol. Carboxylate, it's called oic acid, methanoic acid, ethanoic acid. Ketone, it's called on, propanon or butanon. You can remember the prefix also. 3 carbon, it's prop, 4 carbon has a would you like but. Okay, we can discuss is a homologous series. Previous this series is group of carbon compounds having a similar structure, similar chemical properties whose successive member differed by a CH2 groups. Okay, this is alkane, alkene and alkynes. These alkanes have a general formula. It's CnH2n plus 2. Their names end with ANE. Okay, the members follow methane, ethane, propane, butane, pentane. You can see here structure also. Next is alkenes have a general molecular formula is CnH2n. Their names end with ENE and the number are follows as ethene, propene, butene, pentene also. Okay, you can see here anyone there one or more than one double bond in present in this all are called the alkenes. Next, alkynes. Alkynes have a general molecular formula CnH2n minus 2. Their names end with YNE and the members are as follows: ethyne C2H2, propine C3H4, butane C4H6. Okay, you can remember this homologous series. Next, some more important carbon compounds is the ethanol C2H5OH, ethyl alcohol. Ethanol is an alcohol. We can uses of ethanol as a fuel in a medicine, as a solvent, and harmful effect for drinking alcohol damage your liver, causes additions also. Okay, ethanol is a colorless liquid with a pleasant smell and burning taste. It is soluble in water. Ethanol react with sodium to form a sodium ethoxide and hydrogen. You can see the reaction C2H5OH plus 2Na. It gives C2H5ONA plus H2. Ethanol react with hot concentrated H2SO4 to form ethane and water. Concentrated H2SO4 is a dehydrating agent and removes water from ethanol. You can see a C2H5OH, it's react with concentrated H2SO4 C2H4 and it leaves water drops. Okay, uses it used for making alcoholic drink, used for a solvent, used for making medicine like a tincture iodine, cup syrup, and tonics, etc. Okay, next, carbon properties of carbon compounds. This is combustion. Carbon compounds burn in oxygen to form a water, carbon dioxide, heat and light. You can see methane, CH4O2, it gives H2O, water, heat and light. C2H5OH plus oxygen react, it break down in water, carbon dioxide, heat and light. Oh, so okay, this is combustion. Oxidation means in this carbon compound like alcohol or oxide to carboxylic acid on a heating with a oxidizing agent like alkaline potassium permanganate, that is KMnO4, or acidic potassium dichromate, that is K2Cr2O7. Alcohols are oxidized to carboxylic acid. This is a reaction in this C2H2H5OH. It is ethanol. It react with alkaline KMnO4 plus heat or acidic K2Cr2O7 plus heat. And this form of CH3COOH. This is ethanoic acid or acetic acid. Also we call it vinegar, and used in food preservation also. It is carboxylic acid also. Okay, addition reaction. Unsaturated hydrocarbon undergo addition reaction with a hydrogen in the presence of nickel or a palladium as a catalyst to form a saturated hydrocarbons. For example, ethene undergoes addition reaction with a hydrogen to form a ethane in the presence of nickel or a palladium as a catalyst. C2H4 plus H2, it gives C2H6. And then double bond, we can use this bond will be break down. The addition of the hydrogen to unsaturated hydrocarbon to form a saturated hydrocarbon is called hydrogenation. Hydrogenation is used to cover unsaturated oils and fats to saturated oil and fats. Okay, substitution reaction. And this part, saturated hydrocarbon undergo substitution reaction with a halogen to form a substitution products. For example, methane undergoes substitution reactions with a chlorine in the presence of sunlight to form a substitution product. First of all, you can use this example with reaction CH4 methane plus 1 atom is Cl2, it gives CH3Cl plus HCl. Second chlorine add, then CH3Cl, it gives CH2Cl2 plus HCl. And third atom added CH2Cl2, it gives CHCl3 and HCl. Fourth atom gets that all hydrogen are removed and all chlorine are added with a carbon and make CCl4, carbon tetrachloride, and plus HCl. Next, ethanoic acid. It react with metals, bases, and carbonates also. In these properties, ethanoic acid is also colorless liquid with a pungent smell and the sawdust. It's soluble in water also. A solution of a 5% or to 8% ethanoic acid in a water is called vinegar. Esterifications in this reaction, ethanoic acid react with ethanol to form the ester. Ethyl ethanoate in the presence of concentrate H2SO4. You can see here this reaction. First ethanoic acid CH3COOH plus ethanol C2H5OH may react with concentrated H2SO4 and gives CH3COOC2H5 and water drops release. Okay, the reaction between carboxylic acid and alcohol to form ester is called esterification. Okay, first saponification. When an ester react with the sodium hydroxide solution, the sodium salt of the carboxylic acid and the present alcohol are formed. This reaction is called saponifications. For example, ethyl ethanoate react with a sodium hydroxide to form a sodium acetate and ethanol. CH3COOC2H5 ethyl ethanoate react with NaOH and it gives CH3COONaC2H5OH. Okay. Next, ethanoic acid react with bases or to form salt and water. This is CH3COOH plus NaOH. It gives CH3COONa plus H2O. Ethanoic acid react with a carbonate and hydrogen carbonate to form salt, water, and carbon dioxide. You can use this reaction C3COOH plus Na2CO3 be called as the Na2CO3 and it gives CH3COONa plus H2 and water. C3COOH is ethanoic acid react with hydrogen carbonate, sodium hydrogen carbonate and it gives CH3COONa H2O and carbon dioxide also. Next, soap. Soap are the sodium or a potassium salt of long chain fatty acids. Problem we can do not work well in hard water or form a skin also. Okay, soaps are long chain sodium or potassium salt or a carboxylic acid. For example, sodium stearate C17 H35 C and A. Structure of soap molecule. A soap molecule has two parts. A long hydrocarbon part which is hydrophobic means water repelling and soluble in oil and grease and a short ionic part which is hydrophilic means water attracting and insoluble in oil and grease. Okay, you can see this diagram also. Cleaning action of soap. When soap is dissolved in water it forms a spherical structure, it's called micelles. In each micelles the soap molecules are arranged readily such that the HC part is towards the center and the ionic part is towards the outside. The HC part means HC means you can remember now. HC means water attracting. Okay. dissolve the dirt, oil, and grease and form a emulsion at the center of the micelles, which can be washed away by water. You can see this figure out also. Next, detergent work in hard water, do not form a scum using washing powders and liquids also. Okay, cleansing effect actions of um, detergent or a soap molecule have a hydrophobic head and hydrophilic head and hydrophobic tail. They form a micelle trapping grease and washing it away with water. You can revise this. Okay, detergents and long chain sodium salt of sulfonic acid. Soaps do not wash well with hard water because it forms insoluble precipitates of calcium and magnesium salt in hard water. Detergent wash well with hard water because it does not form insoluble precipitate of calcium and magnesium salt in hard water. This different soaps and detergent soaps are sodium salt of fatty acid or detergent are sodium salt of sulfonic acid. Soaps clean well in a soft water but do not clean well in hard water. But the detergent clean well with both hard and soft water. Soap do not clean as well as detergents and detergent clean better than the soaps. Soap are biodegradable and do not cause a pollution. Some detergents are non-biodegradable and cause a pollutions. Okay, in this chapter we learned the importance of carbons, hydrocarbons, functional group, ethanol and ethanoic acid, soaps and detergent. If you found this video helpful, please like, share and subscribe to the channel. Comment below if you want a numericals board exam questions or a note PDF. Thank you for watching.